Hi, Gia. How are you? I just wanted to record this video for you to show you how to use R for FSQ analysis. This is straightforward and it's very easy. I will send you also the two packages for the R, but I'll show you how to use them here. First of all, the first thing that you need to do is that to convert or to create a new data set for the R packages. And if you see here, I have 6 columns, but that gender and then some construct like perceive, attitude, perceive, behavior, control, intention, social norms, and self-efficacy. Let's say that in the original data set, you have 4 items for self-efficacy. In order, let's say that it's like self-efficacy 1, self-efficacy 2, self-efficacy 3, and self-efficacy 4. And then respondents number 1 has given 4, 5, 5, and 4 to this. From 1 to 7 Likert scale, and then here you need to take an average for this respondent for all 4 items in self-efficacy, and then here it will be a new you create a new column based on the average or all the respondents for particular construct. So if you have you need to create a new columns for all your constructs, including your control variables like gender or categorical variables, where you give a binary for gender, for instance, and all the other categorical variables. So here, when you create this one, now I have it here. So there are 6 columns, and then all the average values except the first one, which is a gender that it has binary value. And then you save this as your as a CSV file, and then you go here to the R package here. For instance, you set your directory, and then you import your data set, which was saved as a CSV file. It's called dataset.csv, and then there are 6 columns from column 1 to 6. So, and then you run the code, and then you try here to attach the file to the R. And then here we have the first function that it converts the binary. This is, we have the gender, then the file name is gender, and then you run the code. And then for the Likert scale, we use this code. So you run this one, and this is for converting all the Likert values from 1 to 7. Okay? And then these are the fuzzy memberships here that we have it for 1 to 7. You run this one, and here it's also important. If you see that, for instance, in the new data set that I created, I had the self-efficacy like these. Okay, and now because I want to convert this self-efficacy to fuzzy numbers, so I give a new column names is efficacy underline F. F it means for the fuzzy. And then you run this one, and then you go to the next code where it says that create a new data set and name that the new data set as a FsQCA, and then you run this. And then it means that because in the beginning we had column 1 to 6, and now we created the columns from 7 to 12 in our new data set which is called FSQ. So you run this one, and then you end this code here. So basically, if we go here to new data set, if we see it, now we have 6 new columns that the data have been converted to fuzzy membership. For gender 1 has been transformed to 0, and then for 2 is 1 now here, and then all the rest of the columns they have fuzzy membership here. Then when we are done with this one, then we go to another our packages. Here I just run to clean this part of the environment, and then you need to install 3 packages of R. The first one is for the necessary analysis, and then the other one is for main. Fuzzy FsQ analysis, and then the third one is for plotting your findings or the solutions. So we run this one. Of course, I have already this one, so I don't need to run it once again. And then I try to load the libraries. And then when we are done with it, this is the starting point for analyzing the data. So this is the new data set, which will be now imported to this environment. You can read this later. These are some information for you, but basically here the first code is the necessity analysis, where we want to see that if there are some conditions or construct variables that they have the consistency over 0.9, which are whether they are sufficient or the necessary condition for the outcome to occur. So here my outcome variable is intention, that I have to write the outcome variable here, and then from column 1 and to column 6 I need to check for the necessity analysis, and then here is the inclusion is that I want to get the values, all the values that are above 0.1. So I run this part of the code, and then I get the necessity analysis, which basically we want to get the highest values here. For instance, for gender, the negation of the gender, the consistency is 0.5. And then this is this is the coverage, and this is the consistency, so which are quite fine. And then this is for the presence of the gender. This is for the negation of perceived attitude. This is for the presence of the perceived attitude, and so forth for the others. So basically, these 6 we need them. All the values of each construct, the negation and the presence of the constructs. And then now when we are done with this work, and then we try to create a truth table here. If you see here again, the outcome variables is intention, and then here we have column 1 to 5. I put the consistency cutoff value 0.85, and then the frequency cutoff is 1. So here you can also change it to 2, for instance, if you want. And then you run the truth table, and then here you get the truth table values in this part. And then we go to the main part of the analysis. Here is that we run for complex solutions. So we get the results here, and then we have the parsimonious solutions, and here we run for the intermediate solutions. There is a problem now here, and I don't know what is this problem, but anyway, it should work basically. Let me see if this works. Let me fix this one and then I come back. I don't know what was the problem, but anyway, here I changed something here that to show that I want to have all the conditions or variables in the analysis. So we have and I want them to be all present. And then I run here. So this is the final intermediate solution of my analysis. This is what you report. Here you have the consistency value. Here you have the coverage values, and everything is now smoothly run by this software. And now I try to also show you something on a PLS, that how to create a multi-group analysis. Let me just open my PLS and then I come back to you. Hi again. Now I have opened my PLS, and I want to show you how to create a new group analysis here. Let's say that here your data set, so you double click on your data set, and then you go here to add a data group. You call this data group as a gender, for instance, and then you go to here to find your variable. It's gender. It's equal to, and then you have the values 1. So this is one group, and then you go again to another one. This should be actually the first one should be male, and this one will be female group. And then you go to the variable gender. The value is equal to 2. Then we create like this. So this is a female, and then here now the gender should be renamed to male. And then that's all. So now we have 2 groups here, female and male, the number of the observations, and then you go to your model. You click on calculate PLS algorithm, and then here you have the group data groups that you want to run the model based on these 2 groups, and then you start calculation. And here when you get the reports, here you see that you have all the values like this one, for instance, the construct reliability for the complete model. Then you have another one for the female, and then you have a male also. So this is basically how you create and you run your model. If you want to see the significance value, then you go to bootstrapping, and again you choose both groups, and then you start the calculations. And now the data will be analyzed based on the full data set, and then based on the 2 groups, female and male, in this calculation, and then we get all the results for both groups. Again, the same thing. You go to your report, you run it, you see all the significance value here. This is for complete model, this is for male, and this is for female. So basically you can add even more groups into your data set and then run it. I hope this was informative for you, and I'll also read your paper later and then come back to you. Okay, take care and say hi to the professors also. Bye.